On a clear day in the Pacific Northwest, it dominates the horizon, a colossal, glacier-clad peak rising more than 14,000 feet into the sky, so massive and so beautiful that locals simply call it the mountain. Mount Rainier is the crown jewel of Washington state, a beloved icon visible from Seattle and Tacoma and the millions of homes spread across the surrounding lowlands. To the people who live in its shadow, it is a source of pride, a postcard backdrop, a symbol of the region's natural grandeur. But beneath that serene and majestic surface lies a truth that most of those millions rarely think about, a danger so quiet and so slow to reveal itself that it has earned a chilling reputation among the scientists who study it. Mount Rainier is one of the most dangerous volcanoes in the United States, and the threat it poses is not primarily the fiery eruption most people imagine. It is something stranger, faster, and in many ways more terrifying, a wall of mud and rock and debris called a lahar, capable of racing down the mountain's flanks and burying the valleys below. Valleys that are now home to hundreds of thousands of people in the greater Seattle-Tacoma region. This is the story of the danger nobody sees coming, the lahar that could reshape the map of the Pacific Northwest, and why the very people most at risk so often have no idea they are living in its path. Before going further, it is essential to be clear about something, because responsible discussion of this danger demands it. Mount Rainier is not erupting, and there is no sign that an eruption is imminent. The mountain is quiet, monitored closely, and the scenario described here is not a prediction that catastrophe is about to strike. The timing of these events cannot be predicted, and they may not happen for a very long time. The purpose of understanding this danger is not to spread fear, but to explain a real and well-documented hazard, to appreciate the remarkable science that has been developed to confront it, and to understand why preparation matters even for events that are rare. With that firmly in mind, we can explore what makes Mount Rainier so uniquely dangerous, and why the threat of the lahar is one that everyone in its shadow should understand. What exactly is a lahar? To understand the danger of Mount Rainier, you first have to understand the word at the center of it, a word that most people have never heard. Lahar. A lahar is a volcanic mudflow, but that plain description does not begin to capture what it actually is or why it is so terrifying. A lahar is a fast-moving slurry of water, mud, rock, sand, boulders, and debris, all mixed together into a churning flood that has roughly the consistency of wet concrete. It flows down river valleys and drainages from a volcano, and it can travel at high speeds, tens of miles per hour, carrying an almost unimaginable destructive power. A lahar is not water that you could swim in or wade through. It is a dense, abrasive, battering flood of debris, capable of carrying boulders the size of cars, of snapping full-grown trees, of tearing buildings from their foundations and grinding them to pieces, of burying everything in its path under many feet of concrete-like sediment that then hardens in place. The reason lahars are so dangerous and so uniquely associated with a mountain like Rainier has to do with what the mountain is made of and what sits on top of it. Mount Rainier is an enormous volcano, but it is also the most heavily glaciated peak in the contiguous United States, cloaked in a vast mantle of ice and snow, an immense reservoir of frozen water perched high on its slopes. When you combine that enormous store of water with the loose volcanic rock and debris that makes up the mountain and add some trigger that sends it all rushing downhill, you get a lahar. The water and the rock and the mud combine and cascade down the mountain's river valleys, gathering more material as they go, growing in size and power, and racing toward the lowlands below. Rainier is, in a sense, perfectly configured to produce these flows, a huge, steep, ice-covered pile of weakened volcanic rock looming directly above populated valleys. It is this specific combination that makes the mountain so dangerous, and the lahar so central to its threat. Why Rainier is different from other volcanoes. When most people picture a volcanic disaster, they imagine the dramatic scenes of an eruption, rivers of glowing lava, towering clouds of ash, explosions of fire and smoke. And volcanoes certainly can produce those things. But the peculiar and frightening truth about Mount Rainier is that its greatest threat does not require any of that. The most dangerous thing about Rainier is not the lava or the ash, but the mountain itself. The vast quantity of ice and weakened rock that can come crashing down as a lahar even without a major eruption. This is what sets Rainier apart and makes it so insidious a danger. The mountain's threat is amplified by a process that has been quietly at work inside it for a very long time: the chemical weakening of its rock. Over thousands of years, hot acidic fluids circulating within the volcano, a process called hydrothermal alteration, have been chemically transforming portions of the mountain's solid rock into weak, crumbly, clay-rich material. In effect, parts of the mighty mountain are slowly rotting from within, their once solid rock turned soft and unstable. This is critically important because it means that portions of Mount Rainier are structurally weakened, primed to collapse. And here is the truly unsettling part: such a collapse could happen without any eruption at all. A large section of the weakened flank of the mountain could give way and come crashing down under the force of gravity alone, perhaps triggered by an earthquake, perhaps by the steady work of water and ice, perhaps by nothing more than the accumulated weight of instability finally reaching its breaking point. That collapse, mixing with the ice and snow and water of the glaciers, would transform into a massive lahar, roaring down the valleys below, without warning, without the buildup of an eruption, without any of the obvious signs that might give people time to react. This is the danger nobody sees coming. In the most literal sense, a catastrophe that can be unleashed not by a fiery eruption announcing itself for weeks in advance, but by the silent, sudden failure of a mountainside that has been rotting quietly for millennia. The valley's in the path to grasp why this matters so much. You have to understand the geography of what lies below Mount Rainier, because the mountain does not stand in isolated wilderness. Its river valleys, the natural pathways that a lahar would follow, lead directly down into some of the most densely populated areas of the Puget Sound region, the sprawling lowlands between the mountain and the sea, where the great cities of Seattle and Tacoma and their many suburbs have grown. The rivers that flow off Rainier's flanks have, over thousands of years, built the very ground on which these communities now sit, depositing the sediment of ancient lahars to create the flat, fertile valley floors that were so attractive for settlement and development. In a profound and unsettling irony, the very land that makes these valleys desirable places to live was created by exactly the kind of catastrophic flows that now threaten them. The communities in the path are numerous and growing. In the river valleys that lead down from the mountain sit towns and cities that have become bedroom communities and industrial centers of the Seattle-Tacoma metropolitan area, places where hundreds of thousands of people live, work, and go to school. Some of these communities sit directly atop the deposits of past lahars, built on ground that was itself laid down by previous flows from the mountain, ground that stands as silent geological testimony to what has happened before and can happen again. The town most often cited as being in the greatest danger sits in a valley directly downstream of the mountain, built squarely on the deposits of a massive prehistoric lahar. With a large population living in what scientists identify as one of the most hazardous locations, it is a place where the school children practice regular drills, taught from a young age to move quickly toward the high ground at the edge of the valley when the sirens sound, a sobering routine that has become a fact of life for a community that lives, quite literally, on the ground a past lahar built, but it is far from alone. All along the river valleys leading from Rainier toward Puget Sound, communities have grown and spread across the floodplains and lahar deposits, often with little awareness among their residents of the geological history beneath their feet or the mountain's shadow that hangs over them. And these flows, following the river valleys, could carry their destruction far down toward the lowlands and the industrial areas near the sound, reaching toward the edges of the region's largest population centers. The valleys are the highways of the lahar, and along those highways live the people most at risk. The evidence written in the ground, the reason scientists take this threat so seriously, is not speculation, but history. A history written clearly in the ground itself, in the deposits left behind by lahars that have already happened. Mount Rainier has produced enormous lahars many times in its geological past, and geologists have studied their deposits in detail, reading the layers of the earth like the pages of a book that records the mountain's violent history. Those deposits tell a sobering story. The valleys below Rainier have been inundated by massive lahars repeatedly over the past several thousand years, some of them so large that they traveled all the way down to the lowlands where major communities now stand. The most famous of these past events is a truly enormous lahar that occurred roughly 5,000 years ago, a flow so vast that it is estimated to have covered an immense area of the lowlands, burying the valley floors under many feet of debris and reshaping the entire landscape. This ancient flow, associated with a major collapse of the mountain summit, traveled tens of miles from the mountain all the way down into the areas where large populations now live. The scale of it is difficult to comprehend, a wall of mud and rock that swallowed entire valleys and buried the ground on which cities would one day be built. And this was not a unique event, but one of many, part of a long pattern of lahars large and small that have swept down from the mountain again and again over the millennia. The geological record makes clear that these are not freak occurrences, but a recurring feature of the mountain's behavior, a natural process that has happened many times and on the long timescale of geology will happen again. This is why the scientists who study Rainier speak of the lahar threat not as a remote hypothetical, but as a matter of when, not if, on a long enough timeline, a certainty written in the layers of the earth, even though its timing remains completely unpredictable and may lie far in the future. How fast and how far? Part of what makes the lahar threat so frightening is the combination of speed and reach, the way these flows can travel far and fast, giving the people in their path precious little time to escape. A large lahar descending from Mount Rainier would not creep gently down the slopes, it would race down the steep upper valleys at high speed. And even as it reached the flatter lowlands and slowed somewhat, it would still move faster than a person could run and would continue traveling for a very long distance. The flows follow the river valleys, funneled and channeled by the terrain, and they can maintain their destructive force over many tens of miles, reaching communities far from the mountain itself. For the communities closest to the mountain, in the upper valleys, the time between the start of a lahar and its arrival could be shockingly short, a matter of minutes to perhaps an hour or so, depending on the size and origin of the flow and the distance involved. For communities farther down the valleys, there would be more time, but still, the window would be limited, measured in tens of minutes to a few hours. This is the brutal arithmetic of the lahar threat, a flow moving at the speed these do, through valleys this steep, toward populations this large, leaves very little margin for warning and escape. And the danger is compounded by the fact that in the case of a lahar triggered by a flank collapse rather than an eruption, there might be no warning from the mountain at all before the flow began, no rumbling buildup, no ash, no signs to alert people that anything was wrong until the debris was already rushing down the valley. The speed and the potential lack of warning together create a scenario in which the difference between survival and catastrophe could come down to mere minutes, and to whether the people in the path know what to do and have somewhere to go. The warning system racing against the flow confronted with this daunting threat, scientists and emergency managers have not simply thrown up their hands. They have built something remarkable, a lahar detection and warning system designed to give the people in the valleys the one thing that could save their lives, which is time. Understanding this system is essential because it represents the primary line of defense against a danger that cannot be prevented, and it embodies a genuine and hopeful example of human ingenuity confronting a force of nature. The lahar warning system works by placing sensors on and around the mountain and in the river valleys. Instruments designed to detect the telltale signs of a lahar as it begins and starts its descent. These sensors can pick up the ground vibrations that a massive flow of debris produces as it moves, the distinctive shaking that announces a lahar racing down a valley. When the sensors detect the signature of a lahar, the system is designed to trigger alarms, sending out warnings to the communities downstream, activating sirens, and alerting emergency officials so that people can be told to evacuate immediately to higher ground. The entire purpose is to buy time, to detect the flow as early as possible and get the warning out ahead of the debris, giving the people in the valleys those precious minutes they would need to flee upward, away from the valley floor, to the safety of higher elevation. Because a lahar follows the low ground of the valleys, the escape is often a matter of getting to high ground, of climbing out of the path of the flow, and even a few minutes of warning can be the difference between reaching safety and being caught in the debris. This system has been developed and improved over the years, and it stands as one of the most important tools for protecting the people who live in Rainier's shadow. But a warning system, however sophisticated, is only as good as the response it enables, and this is where the human element becomes crucial. A siren means nothing if people do not know what it signifies or what to do when they hear it. A warning provides no protection if people do not know their evacuation routes, if they freeze in confusion, if they try to drive when the roads are jammed, if they simply do not react in time. The technology can detect the lahar and sound the alarm. But survival depends on the people in the valleys understanding the danger, knowing the plan, and acting instantly and correctly when the moment comes. This is why education and preparation are so vital, and why the communities at risk practice evacuation drills, teaching residents and especially schoolchildren to move quickly to high ground when the sirens sound. The warning system and the human response together form the defense against the lahar, and both must work for that defense to hold. The people who do not know, perhaps the most troubling dimension of the entire Mount Rainier lahar threat, is captured in the phrase "the lahar nobody sees coming," and it applies not only to the potential suddenness of the flow, but to something deeper and more human: the widespread lack of awareness among the very people most at risk. Many of the hundreds of thousands of people living in the valleys below Rainier have little or no understanding of the danger they live with, no real sense that the beautiful mountain on the horizon could one day send a wall of debris racing toward their homes. They see the mountain as a scenic backdrop, a symbol of natural beauty, not as the source of a catastrophic hazard. And this gap in awareness is itself one of the greatest dangers. This lack of awareness is understandable. The last truly enormous lahar was thousands of years ago, far beyond living memory, and the mountain has been quiet throughout the entire history of modern settlement in the region. The valleys have been developed, populated, and built up during a period of volcanic calm. And to the people who moved there, the ground beneath their feet is simply solid ground, the mountain simply a lovely view. The geological timescale on which lahars occur, with major events separated by hundreds or thousands of years, is so far removed from the timescale of human experience that the threat feels abstract, unreal, easy to ignore, or never even to learn about. And so people build their lives in the valleys, raise their families, send their children to schools that may sit directly in the path of a potential flow, all without a clear understanding of the hazard beneath and above them. This is the human tragedy embedded in the lahar threat, that the danger is greatest precisely where awareness is often lowest. That the people most in need of knowing are frequently those who know the least. Closing that gap in awareness, ensuring that everyone who lives in the valleys understands the danger and knows how to respond, is one of the most important and most difficult tasks in confronting the threat, because a prepared population can survive a lahar that would devastate an unprepared one. The flow itself may be unstoppable, but the loss of life is not inevitable if people know, and if they are ready. Why it is so hard to prepare, given the severity of the threat in the century or more that modern communities have existed in Rainier's shadow, one might ask why the region has not simply prevented people from living in the most dangerous areas, or done more to reduce the risk. The answer reveals the profound difficulty of confronting a hazard like this, a difficulty rooted in the collision between geological reality and human reality. The lahar threat unfolds on a timescale so vast, and with a probability in any given year so low, that it is extraordinarily difficult for communities to justify the enormous costs and disruptions that truly addressing it would require. Consider the situation. The valleys below Rainier are home to hundreds of thousands of people, to entire cities, to homes and schools and businesses and industries representing enormous economic value built up over generations. The land is valuable, the communities are established, and the economic and social forces driving continued development in these areas are powerful. To meaningfully reduce the risk by preventing development or relocating populations away from the hazard zones would be extraordinarily expensive and disruptive, requiring communities to forgo growth and residents to abandon their homes in the face of a danger that might not materialize for centuries. Against the certainty of those immediate costs stands only the low annual probability of a catastrophe that, while devastating, is statistically unlikely in any given year or even any given lifetime. Faced with that calculation, communities have generally chosen to continue living and building in the valleys, managing the risk through warning systems and preparedness, rather than through the far more costly path of avoidance. This is not necessarily irrational, but it does mean that the exposure continues to grow as more people move into the valleys and more is built in the path of a future flow. Each passing year of quiet makes the threat feel more remote and the case for costly precautions harder to make, even as the population at risk continues to expand. This is the fundamental dilemma of the low probability, high consequence hazard. The very rarity that makes it easy to ignore is what allows the exposure to grow, until the day the improbable finally happens and the accumulated risk comes due all at once. The triggers that could set it loose. To fully understand the danger, it helps to consider the various ways a lahar could actually begin. Because there is not just one path to catastrophe, but several, and this multiplicity of triggers is part of what makes the threat so persistent and so hard to guard against. The most obvious trigger is a volcanic eruption. If Mount Rainier were to erupt, the heat could rapidly melt vast quantities of its glacial ice and snow, sending torrents of meltwater cascading down the slopes, mixing with rock and debris to form enormous lahars. An eruption-driven lahar would in some ways be the most anticipated, because the volcanic unrest leading up to an eruption, the earthquakes, the ground deformation, the emissions, would likely provide days or weeks of warning that something was happening, giving authorities time to prepare and potentially evacuate. In that sense, the classic eruption scenario, for all its power, might be the one that comes with the most warning. But the more insidious triggers are the ones that require no eruption at all. As discussed, large portions of the mountain have been weakened by hydrothermal alteration into unstable, clay-rich rock, and such weakened material can fail and collapse without any volcanic activity to prompt it. A powerful earthquake, of the kind the seismically active Pacific Northwest is capable of producing, could shake loose a weakened flank of the mountain, sending it crashing down as a debris avalanche that transforms into a lahar. Or, the collapse could happen with no obvious external trigger at all, the weakened rock simply reaching the point of failure under the relentless pull of gravity and the slow work of water seeping through it. There are also smaller scale triggers that can produce more localized but still dangerous flows. Heavy rainfall or rapid snowmelt can mobilize loose debris on the mountain slopes, and the sudden release of water from within or beneath the glaciers can send flows down the valleys. These smaller events, while not on the scale of the Great Collapse-driven lahars, still pose real dangers to those in the immediate river valleys, and they occur more frequently. The variety of triggers means that the threat is not confined to the rare scenario of a major eruption, but is a persistent background hazard, present in some form at all times, capable of manifesting in many different ways and on many different scales. This is why the mountain is monitored continuously, and why the warning system watches the valleys even in times of complete volcanic quiet. Because the lahar does not need an eruption to announce it. The monitoring that never sleeps. Standing against this ever-present threat is a continuous, sophisticated monitoring effort, a scientific vigil kept over the mountain around the clock, and understanding it offers a measure of reassurance amid the alarming realities. Mount Rainier is one of the most closely watched volcanoes in the country, studied and monitored by teams of scientists using an array of instruments designed to detect any sign of change or unrest. Seismometers listen constantly for the earthquakes that might signal magma moving beneath the mountain or rock beginning to fail. Instruments measure the subtle swelling or deformation of the ground that could indicate rising magma. Other tools watch for changes in the gases emitted by the volcano, in the temperature and chemistry of its hot springs, and in any of the other signals that might herald a change in the mountain's behavior. This monitoring means that, in the case of a threat driven by volcanic reawakening, scientists would very likely detect the warning signs and be able to alert the public well in advance. The value of this monitoring is enormous, and it represents the front line of the effort to protect the region. If the mountain begins to stir, the scientists watching it would very likely know, and that knowledge could translate into the time needed to prepare and evacuate. But the monitoring also underscores the humbling limits of what science can do, Because the scenario that most concerns experts, the sudden collapse of a weakened flank with no volcanic buildup, is precisely the one that might give the least warning, occurring without the seismic and deformation signals that would precede an eruption. This is why the lahar detection system in the valleys, the sensors watching for the flow itself rather than for signs of eruption, is such a vital complement to the monitoring of the mountain. Together, the mountain monitoring and the valley detection form a layered defense, the first watching for the volcanic unrest that might lead to a lahar. The second watching for the lahar itself once it has begun. Neither alone is sufficient, but together they represent the best that current science and technology can offer against a threat that cannot be prevented, only detected, warned against, and fled. The vigil never sleeps, because the mountain, for all its serene stillness, is never entirely at rest. And the people who keep watch over it understand that their attention is one of the things standing between the communities below and disaster. The deeper lesson of the mountain stepped back from the specific mechanics of lahars and warning systems, and the story of Mount Rainier offers a profound lesson about the relationship between human beings and the powerful natural forces among which we live, often without fully realizing it. The millions of people in the Puget Sound region go about their lives in the shadow of a mountain that is at once a beloved symbol and a sleeping giant, a source of beauty and a source of danger, and most of them rarely if ever think about the second of those truths. There is something deeply human in this. In the way we build our lives on beautiful and fertile ground without always reckoning with why that ground is there or what created it, in the way we grow comfortable in the long quiet between rare catastrophes, in the way the very stability of our daily experience blinds us to the geological forces that shaped and could reshape our world. The lahar nobody sees coming is, in the end, as much about human perception as about geological reality. The flow itself, when it comes, may indeed arrive with little warning, but the deeper blindness is the one that exists in the years and decades of quiet, when the danger is known to scientists, but invisible to the public. When the warnings and the preparations and the awareness that could save lives fade into the background of ordinary life. The mountain will do what mountains do, on its own vast and indifferent timescale, and no human effort can prevent the lahar that geology has written into its future. But whether that future flow becomes a manageable disaster or an unimaginable catastrophe depends enormously on what the people in its path do in the long quiet beforehand, on whether they learn the danger, heed the warnings, build the systems, practice the escapes, and hold in their awareness the knowledge that the beautiful mountain is also a threat. Preparation cannot stop the lahar, but it can determine how many people survive it, and that is not a small thing. It may be the difference between a tragedy the region mourns and recovers from and a catastrophe from which it never fully returns. For now, Mount Rainier stands serene and magnificent on the horizon, its glaciers gleaming in the sun, its slopes quiet, its danger dormant. There is no cause for panic, no sign whatsoever that the mountain is about to stir, and no reason at all to believe that any catastrophe is near. But there is every reason to understand the danger, to respect it, and to prepare for it, so that when the mountain does eventually do what its long history promises it will, the people who live in its shadow are ready to survive. The lahar nobody sees coming does not have to be the lahar that erases everything. With knowledge, with vigilance, with preparation, it can be the disaster that a ready region weathers and rebuilds from. That is the choice that lies before the communities in the valleys, and it is the choice that the quiet years are for. The mountain is watching over them, beautiful and terrible at once, and the wisest response to its silent presence is not fear, but a calm and steady readiness. The patient, unglamorous work